So this evening we're joined with Mike from Ceecom Antennas, and we've got a prize draw in a little while. But thanks very much, Mike, for coming again and supporting our radio network. It's good to see you after the Hamzilla. I know you've been busy and you've got a lot in the pipeline, but we'll crack on and pass it over to you and enjoy the evening. Thanks very much for coming.
Thank you, Andy. How are you, mate? Are you all right?
Yeah, I'm all right. I'm not too bad.
Good.
Yeah,
Good. I was I'm not sure what to expect, so let me just sort that. Are you going to bombard me with questions, or
yeah, we can. Yeah, because since I last saw you at Hamzilla, you said that you had some different various bits and pieces in the pipeline that you was going to be considering branching into. So,
Yeah.
what have you been up to then in the past 7 months? What's been going on? Where is Ceecom Antennas at the moment, and what do you see coming for the Hamzilla in March 2023?
So we've been working on a few bits and pieces. I don't want to give too much away in case they don't work. But so we, using the existing moulds we had from the dipole, we've been making the Moxons. I didn't think they'd do very well. I made 30 of each for Hamfest.
Yeah.
And they all sold out straight away. So they're quite a popular antenna. Had various other moulds made in the meantime. What have we got? Let me show you this. So based on the dipole with the SO239 connector and the N-type connector, with me, lots of people are asking for antennas with balance on and so on. Because obviously then dipoles are just open dipoles. So using the same mould, I don't know if you can see that on there.
Yes.
We got that. So this has got the option for 3 entry points for RG213 or LMR 400. So on this particular dipole, it's just the same dipole, but with a, bear with me, a Porsche stub. So 2 pieces of coax, and they run down into these. So that's one little thing we've been working on. So the Moxon can have a Porsche stub on it if you want it. Same with the open dipole. So they're being made at the minute. What else have we been working on? Got the moulds in place for a bigger dipole centerpiece. So the current mould, let me show you the mould. Andy, not very organised. So the current moulds we use at the moment for the dipoles are these here.
Yeah.
Okay? And you can see the shape of it there, and they go into the machine. But that only accepts up to 15.8 mil diameter aluminium, 5/8 inch. So we want to start making some bigger dipoles and some beams and so on. So I've got the mould in at the minute. You can probably see it on my screen there.
Yeah.
Bear with me. So that's the new mould I've been working on last week, and that's being machined as we speak. So that will accept up to 1 inch tubing, 7/8 inch. So we can make some much bigger dipoles. It takes an 8 mil mounting bolt, and it fits onto a much bigger boom arm. So we've got that coming. The last month or so, I've been working on a cobweb antenna. You gave me the idea at Hamzilla.
Yes. Yeah.
So there've been loads of bits and pieces on that. Now, with every antenna I make, obviously it needs to be posted, and that becomes a big issue with size and being able to break antennas down into small parts, small packages.
Yeah.
So the cobweb's been quite a problem to do that. Now we've got a load of fiberglass tubing coming in. With fittings we've had machined. I've drawn them all up in AutoCAD to be able to put the pieces together. I've drawn the center hub for the cobweb, and I'm just playing around at the minute trying to get as much bandwidth as possible on each band. So they will be coming soon, and we'll definitely have them for Hamzilla when it's there.
Right, cool.
Yeah. What else have we got? That mould I just showed you with the 2 coaxes coming out, you can put a 4-to-1 balun on there. So we're going to be making some double ZEP antennas as well. A lot of people have been asking for something for 70 megs, 4 meters with a bit of gain on it rather than just a straight antenna. Obviously, the height becomes an issue and getting the strength on the antenna. So got double ZEP, and we've got a collinear style as well with a matching coil halfway up. That's coming. There's a lot happening. Over the past couple of years, obviously we had baby and we moved house, and as you know, Ceecom sort of got pushed to the side. But I'm getting a lot more time now to focus on it. So this is my year, Andy.
Good.
So yeah, we're getting there, mate. We're getting there.
Yeah, that's good. Yeah,
Yeah.
hopefully we'll see you in 2023 and be racing along.
And I'll be even fatter.
Nice. Well, join the club.
I'll say one thing to you, Mike.
Yes.
About your cobweb.
Yeah.
Yeah. As you know, I've got one. There is a attachment that my mate has made. Okay. For the cobweb, and it goes on top of the scaffold pole that you normally put them on, and it allows you to actually lower the cobweb down in high winds and then hoist it back up again. And it is a really easy bit that you could make.
Well, that was one of the things in the design. So on this design, whether I can pull it off or not, I'm still working on it. I was trying to make the 4 arms that come out.
Yeah, yeah.
Trying to make it so it's strong, but on a pivot arm that can lock in. And with each, I've not got a drawing actually to show you, but it's got the ropes to hold it. It's going to be quite a big one, and I was toying with the idea of being able to lower it down so it all just drops down, if that makes sense. Without having to lower them off.
Yeah. It actually does make sense. Yeah, yeah.
But it's just it's getting the moulds and obviously the cost involved in getting the moulds and so on. So there's a lot involved in it. But I'll be honest, I bought a couple of cobwebs from eBay. I'm not going to say where; it's not fair, but I was really shocked actually at the quality of them and the price. Quite poor. So I personally wouldn't sell it, if that makes sense.
I bought one from Poland.
Okay.
And it works terrific.
Good, yeah. And that's is that got folded dipole elements on it, or has it got the ballon with a ferrite core to bring impedance up?
Yeah, it's got the ballon in the centre. In the box, yeah. I've got pictures of all of it, the whole thing.
Yeah, okay.
That I could send you if you're interested.
No, so I might already have one.
The legs are yellow. The legs on it are yellow.
So Mike, when you're doing a cobweb, I've noticed that MFJ do some.
Yeah.
But they only seem to be like a couple of 100 watts that they will take. Obviously, if you're doing one, you need one that's going to take a bit of power.
So what I've been trying to do, I like the idea of the ballon with the ferrite cores and stuff, because you only have single wires going around as a dipole.
Yeah.
Now, from the experiments I've done, I'm getting probably another, it's not much, but another probably 300 or 400 kilohertz bandwidth by folding the elements back.
Right.
So folded dipole, and then you don't need the ballon to bring up. Basically, when you fold the dipole into the circular shape or the square shape, the impedance drops right down to about 12 and a half ohms. So you need something to bring it up. Now, by folding it into folding it back on itself, it actually brings itself up to 50 ohms. It's times 4, isn't it? A bit like a folded dipole, you'd have 2 or 300 ohms. So by folding it around, but I'm just toying with the idea. I've been making these double ZEPs the last couple of weeks, and I'm just playing about in a minute by having a folded dipole going around, but extending it with a single element, a bit like a what's the antenna? The bazooka antenna.
Bazooka, yeah.
Yeah, so very similar to that, but folded around. So at the moment, it's still I'm just experimenting.
Doing the experimenting.
I just want to get as much bandwidth as possible on each band, but be able to adjust it slightly as well, if you need to.
Okay.
Yeah, and just to give you an idea, it's very crude. I was just playing with this last night. It's a bit of wood. And you can see them phone up. I just trying, it's just in the workshop to experiment what gives the biggest bandwidth and so on. But and as well, by folding the elements back, we don't need to use a balance, so it's not restricted on. We do need to use a balance, of course, because it's a balance to unbalanced coax, but it's not restricted on the ferrite core, so we can use a coax on the core or coil up the coax and so on. I'll get there, Andy.
Yeah, I'm sure you will, mate.
Work in process, but I want to make the best cobweb there is.
Yeah. Okay. And then what? Hex beam. 2023.
Yeah, well,
Will we see the hex beam?
Yeah, it used the same molds, won't it? So that's that. And also from the same mold. And I made this about a month ago, a very small HF antenna to go on like a balcony.
Right.
A good friend of mine lives in the Isle of Wight, and he's got a balcony. He's not got much room.
Right.
Now, there's a website. There's a website out of Harry Liffle, I think his name is. He's a ham in the States, I believe, and he's got some really nice designs on his website. Now, he's got a very nice HF balcony antenna, which is about the size of this. Actually, I'm holding, but the wire goes round and round and round, and it makes up the length. It's not obviously as efficient as a full-size antenna, but it's more efficient than not having an antenna at all, if you know what I mean.
Yeah.
So we got that. That will use the same molds as well. So this one mold for the cobweb can be adapted to make quite a nice range of antennas. So that's my plans going forward.
And washing lines.
Yes. Well, that's what happened actually. The wife ordered a washing line, and that gave me the idea. I took it apart within about 5 minutes. She wants me dead.
So could I ask a question? What effect does folding that element have on the beam pattern?
Well, again, I've been modelling the antenna. The cobweb's actually quite directional. All the spec on MFJ and everywhere else say omnidirectional, but when you actually model it, the side where you feed it, so where the coax goes in, and then the end flow back, the power's that way and that way. There's nulls on the side. So I've been again playing with that to try and get the power equal, but I don't think that's going to be possible. It's still omnidirectional, but you know, if you look at the pattern of any cobweb. What was your question? Sorry, what does folding it back do to the pattern?
Does folding the end of the element around have any effect on the beam pattern?
That I couldn't tell you. I need to model it. I'm pretty sure it would do. Yes. You mean just if it was a single element and you fold it back to shorten it? Is that what you mean?
Yeah, I mean, you said that the principle of folding back the end of the element so that it's easier to match it.
No. What I meant was, sorry, it's a complete folded dipole. So it's your feed comes in, it goes out, and it loops all the way around. So one complete loop. So it's a short,
okay.
Yeah, and then that loop itself's folded round. I don't know if you can see that on there. It's very crude, but so you'd normally have the single wire coming up, and it would end there, wouldn't it? But folded dipole folds back and goes all the way back round through the centre and round the other way. Make sense? Yeah. So that's given the most bandwidth at the minute. But we'll see. Might all be wrong.
I've got one more question, and then if anybody else has got any questions, they can ask you before we start your presentation you've got for the evening. Within your processes, like for example, when you're making a mold, what's the kind of process that you have to go through? Is it sent off to be made, and do you just need to, you know, are you like just saying to somebody, right, this is what I want, it needs to be this? So you're actually hands-on doing all the drawings?
No, so all the drawings. So this mold here, let me show you. So it starts off. Bear with me, Andy.
No worries.
Oh, I've lost it. Hold on. So I take all the measurements of everything, the pipes I want to use, the poles I want to use, the tubes, the fittings. You have to be very careful as well with the mold, because the mold, obviously, I've not got proper molding injection machines like big companies have where it's spewing them out. It's a real slow process. But the mold has to come apart. So if you had a little sticky out bit on the mold, like that cluster, if that was down on the side, I wouldn't be able to get it out the mold, if that makes sense. It would. So there's loads to take into consideration, but bear with me. So it starts off, Andy, I'm not the best in AutoCAD either, so it's been a sharp learning curve over the last few years. Excuse me. So I literally draw the boom arm. So that would be the mounting arm the dipole goes on. Then I have to draw the connector, the shape. But yeah, every part of this antenna is drawn by myself. So yeah, I don't give it to anybody.
Yeah.
Bear with me. So for example, that's the element going through the middle of the dipole.
Gotcha.
And just to show you, it's all drawn by me. Look, so you can move that out of the way, and then so that there, I've started putting my name on it now. Ceecom, getting flash.
Yeah.
So that's the reflector part of the antenna, and I'm drawing that into the same mold. So that will be. Bear with me. Never there when you want it, is it?
So it's not as straightforward as perhaps what the point I'm making is. There's more technical expertise needed in what you do, because it's very easy for people to say, "Oh, I can knock up one of them," and it's
definitely, yeah, and you can knock up a dipole.
Yeah, of course.
You can knock up a bit of bamboo, of course.
Yeah.
But yeah, what people don't see when you've got to make, if I sold you a bit of bamboo with 2 wires on, you'd send it straight back to me. So, yeah, it's for example, the new antennas we're just talking about.
Yeah.
Through the middle of the new antennas, we're going to have this fiberglass tube, and this is solid. So unlike the beams, it won't just be a piece of metal. This will slide and be crimped inside.
So it's not going to be able to bend. It'll give it strength. Yeah.
Yeah, and yeah, so and the plastic as well. You want it to allow strength. You want the connections to fit in. There's loads to it, Andy, that you don't see.
Yeah.
And a bit like the J poles. Making the J poles. Let me find you a J pole fitting. Bear with me. So the J poles. You might recognise that from the J pole.
Yeah, of course. Yeah.
One balance. So what I used to do was cut these tubes, and then I'd have to wrap wire around and do a little TIG weld on it to attach the wire to it.
Yeah.
And a lot of the time it would blow through onto the inside and so on, and it was quite a long process. So what I've started doing now, I found the factory in China, and I sent a little CAD drawing, and they make these for me. So they cut the tube for me.
All right.
The machine, they have CNC machine, punches them holes, which is what you see there. They line up with them.
Yeah.
And then I'm able to put a crimp onto there and rivet it on. So that's what's inside there on the J-pole fittings. But you then got to squeeze your coax in and your connector and do all the connections. So that sits in a mould. Bear with me. So that mould there, you might recognise the shape, is that there. So when it comes out the mould, that's how it comes out.
Great.
And then you have a little nut and bolt goes through your fittings and so on. But again, Andy, they take so long to make.
Oh, I can imagine.
And the other problem, the biggest problem with plastic injection and the moulds, so take that J-pole there and this 4:1 balun. You'd cut that on the analyzer and tune it all up. Let me just clear this off the screen, sorry. You tune it all up. The minute you inject the plastic around it, it adds capacitance across it. I think you call it a dialect. I've forgotten the name of it now, but it literally detunes everything. And it's been an absolute nightmare because you have to get the right length for this coax. I've had to do several molds of this with resistors inside and the tubing to simulate the impedance. And then make one, measure it, make another one, measure it again, and so on. Because it literally, it takes about 5 or 6 inches off the coax. That's how much it detunes it. It's the same with the folded dipoles. I've got a mould for a folded dipole, which are pick. So we've got that mould there, Andy, and this. So this is this one has coax going into. This is a commercial one I do for Arkiva. I do a lot of DAB radio stations and FM. So coax goes in here. There's a balun inside here.
Yeah.
But the minute you put the plastic on it, it detunes it all. So it's an absolute nightmare. But yeah, there's so much involved, Andy. It's unbelievable.
Mm-hmm.
So yeah, but yeah, I've made a little video of me making one, haven't I? If you want,
Yes.
want to see that when you're ready.
Do you want me to play it? I'll play it.
Yeah,
now.
okay, yeah. If it works for you, yeah, go for it. Welcome along. How are you guys? It's Mike here from Ceecom. What are we doing today on camera? Why are we on camera? So Andy, go full screen, Andy.
Ham Radio Networks has been pestering me for about, I'd say 3 years, Andy. 2 years, 3 years. No longer, since the start of lockdown when Ham Radio Network started. He's been pestering me like a mad possessive girlfriend. Mike, can you please come on the channel and do a presentation? And I keep saying no. Anyway, last week I gave in, all right. We was at Ham Fest. We sold out loads of antennas. I've been waiting for some stuff to arrive, and I thought, that's solid. I'll do it for you, Andy. So here I am.
Yeah, what's that noise?
It occurred to me this week, I'm not going to be able to show you live me making an antenna. So I'm going to need to hold the camera and so on. So I thought, you know what? I'm going to film it, which is what this is right now. Now, today, I'm going to show you how we make our simple open dipole, okay? I thought everyone knows how to make a dipole, but we'll show you the ins and outs, how we actually come up with this design, how we make it. There's nothing special about this. It's just an open dipole, all right? We've got loads of other stuff, dipoles with baluns, some new antennas.
It's muted, Andy.
A SO239 connector or an N-type. And these are solid. You cannot snap that, all right? They are really rugged. And that's one thing I like to do at Ceecom. Everything I make needs to be unbreakable, okay? Because there's some crap out there. I bought an antenna last week. I was just curious. And I wouldn't sell it how it was. Let's put it that way. So anyway, right, we're talking about the dipoles. Now, inside the dipole are, bear with me, because I'm not organised. Inside the dipole, so that's the tubing we use, 18 gauge, 5/8" aluminium tubing for the dipoles. Inside the tubing, through the centre of the dipole, we use this. Okay, this is fiberglass tubing, and this reinforces the dipole. So that goes inside there like so. All right, I've got a drill set up with a jig on it that drills the holes through this for the mounting bolt and cuts them in the right places. Through the middle of that mounting bolt, through the middle of the fiberglass tube, sorry, we put the mounting bolt. That goes through like that, excuse the dust. So that makes it very solid as well. So even if you cut off all of that plastic, which gives it the strength, you've still got a very strong dipole. Okay, now the next problem I had when I started Ceecom was, how do I get the connector, the SO239 connector or the N-type, to connect to the elements? I don't like the idea of people putting the elements on and doing nuts up, because then it becomes flimsy. You lose your strength. So a standard N-type connector comes with these little flappy solder tacks. Okay, you can bend it round, but they're not very strong, all right, and they're quite thin. So what I do with all the connectors, we file this down slightly, we solder some tinned wire onto here, and we solder the wire into there. Now that solders on to the dipole elements. Now to solder onto the dipole elements, we use these brass rings. Now the brass ring slides down over the element like so, and then this whole lot gets hydraulically crimped. So this element is crimped onto this fiberglass tube. And here's one I've done earlier, bear with me, Blue Peter style. And it ends up looking like that. So that is crimped. They will not come off, they're solid. And that gives you these two little lugs to solder the wires into. Now let me find you a connector. So here's one we soldered earlier. All right, so these will now go in like so, and they solder, bear with me, and the connector is soldered in like that. Inside there, that gets filled with solder.
So there's one done earlier. So that's how we make the insides. Now, how does that now become one of these? All right, it's very simple. We use a mould that looks like this. Okay, that's the bottom of the dipole, that's the top. And this simply sits inside the mould like that. The connector sits in here, we solder the wires on, plastic gets injected. Now to inject the plastic, again, everything is done in-house here, all right? I haven't bought any fancy machines. We've made the machines ourselves. So this here, let's bring that forward, is a homemade plastic moulding injection machine, all right? Plastic goes into this hole here, gets heated up to about 230 degrees. Hydraulic round comes down, sorry, pneumatic round comes down, pushes the plastic out into that mould. Now that took some getting right. There's a knack to it. You've got to get the plastic the right temperature, the right pressure. You can't heat it for too long, but I've nailed it, all right? And we've got that as the end result, okay? Very solid parts. Now we use the same process for our J-poles and everything else. So what I'm going to do now, I'm going to now film making a dipole from start to finish. You're going to see the plastic going in, the soldering, everything involved. All right, I'm going to speed it all up so you're not bored. And that's that, and then we'll chat after. Catch you in a bit. Set up here on the bench is my trusty old pillar drill. I've had this thing years, since I was young. Still running a dream, all right? It's a little bit noisy, but it works. Now, on the what do you call it, the Udemy flip, the base here, all right, I've casted in resin a guide to drill the holes into this fiberglass tube. So this is what goes through the centre of the dipole. It just allows the drill bit to line up with the centre of the tube to get the holes nice and accurate straight through the middle like that. All right, now it's quite dusty when you're doing it, so I set up a hoover attachment within it as well. So the hoover connects in there, all right, it runs away. The tubing simply goes into this tube here, okay, through there. You drill your hole, you push it through until the hole shows, drill it again, push it through and keep going. Now this tube comes in 3 metre lengths. It's just a small bit I've got for this video. But you keep doing that, and then as each one goes through, you mark it in the middle, you know where to cut it, all right? And that ends up with these. So this is what we use to drill our holes. I'll just show you it working. There we go, so let's just pop that hole through there, a little dusty, but that's how it works, all right, works a dream. Nice and simple, okay, no big machines. Right, now the worst part of making these antennas is soldering these bloody connectors. It's just one of them jobs I hate, but it has to be done, so I'm going to do that now. Now to make the soldering a little easier for myself, all right, I made a little jig up. It's just out of a bit of CNS timber. All right, now in the timber, drilled a load of holes, cut it in half, put some wing nuts on, all right? This just makes soldering, makes life easier soldering, all right? So what I do on here, I take the SO239 connectors, or the N-type, all right? And I simply, to do a load in one here, mount them into these holes. Right, now I just solder one. There's no point in me soldering them all for this video because you'll just sit there bored senseless. So right, we've just soldered that. I'm not going to touch it just yet because it's going to be red hot. But that is how we solder our connectors, all right? So the wires are soldered straight on. Right, so we have our fiberglass tube crimped inside the aluminium tubing with the solder lugs, right? So that's ready to go. And as you've just seen, we've done our connector, which looks like this. It's soldered up very nicely, all right? It's not going anywhere. It's much better than the solder tag that comes with it. Nice. We use 14 gauge 2mm wire. However, I do normally go slightly thicker, about 2.5, but just haven't got any with me today. So we've got 2mm wire on there, tinned copper wire. And we're now going to mount that into our mould, all right? So let's grab a couple of bits of timber to sit our mould on. Now, the reason I'm putting it on the timber is because when the mounting bolt goes through there, it sticks out the bottom of the mould here. So this sits into the mould, like so, all right? And that forms that. Now, as you can see, the mounting bolt, which connects the dipole to the boom arm, is sticking out the bottom. Now, we're going to sit on there like that. We're going to take our connector we just soldered. We're going to find a nut for it. And what I do, I stick the nut on there slightly. Okay, and this allows me to seat it. I bend this around as well, like so, to form the shape of the dipole. And this sits in the mould like this. Okay, they go in like that. So that's sitting there now ready to be soldered. For the video, we're putting our glasses on, of course. Just let that cool. Right, that is soldered to the dipole elements. Now we just cut off the excess wire. Bob's your uncle is soldered onto there, all right? It's a very good connection, all right? Better than any bolt and wing nut and so on. It's not going anywhere. Now, that simply goes into the mould, like so. We need to put the wing nut back on. It just pulls the connector into the edge of the mould site. And that is ready to be clamped up and put into the machine for the plastic to be injected. So I'll show you that now. Now the next part of the process is injecting the plastic into the mould, all right? Now, in the mould, there's a small injection hole just there, all right? And it's shaped like that, which allows the plastic to cool before it comes out and so on, okay? There's a bit involved with it. In the machine behind me, we put these polypropylene pellets, okay? We buy these, they're all under the desk here, under the bench, or boxes of it. These are UV treated, all right? So the antenna won't become brittle out in the sunlight, okay? It'll remain as it is, UV stable, I think they call it. Now, the machine's plugged in behind me, all right? We've got a pneumatic ram at the top here. Let's put these pellets over here. Pneumatic ram at the top, okay, which connects to an air compressor, which is down behind me, all right? We've got a great big air compressor here. There's a fan on the back of it, which takes the fumes and extracts them outside. Temperature controller there, so we're set at 230 degrees at the minute. Plastic's in this barrel, it goes down through and it gets injected into the mould, all right? The little pellets I just showed you literally pour into the top there like that. We've overfilled it now, but that's where they go, and they gradually heat up as they go in. That's about it really. Now we're going to have to tilt the camera down to show you it working. And because I haven't got much height in the workshop, I'm now down on my hands and knees, all right? I'd love to have this up on the bench, but the machine's just too tall to do that. Right, so we're going to take our mould. We're literally going to drop it on this bench here, raise up the platform so it's nice and tight. Okay, and now we're going to inject the plastic into it. So we're going to push the lever down. Plastic's going into the mould as we speak. Give it a couple of seconds. And you can hear the compressors running in the background. Let me just turn them off. Okay, so the plastic is now in the mould. Bear with me, right, let me just turn the camera around slightly. Now you can't leave it in the mould too long, otherwise the shape warps due to the heat of the plastic. Now, bugger to undo. Right, and that forms that. There you go. And there you have it. A very strong dipole. Now it's still wet, not wet inside, but it's still very soft. It's red hot at the moment. But that is how we make our dipoles. Now there's one more process. We need to deburr the ends of the tubes, so we use these. One side of this deburrs the outside, one does the inside. And the final process I was just talking about, we now need to cut the slots into the end of the antenna poles to allow the next elements to slide in and be clamped in. So we'll do that now. I'll show you that on our homemade slot cutting machine. Watch your space. Now the next part, I'm having to lean down to get in the camera, is cutting the slots into this dipole. All right, it's still very hot from the machine. They do take a while to cool down. Now, at the moment we've got no slots. If this was a fixed dipole, it'd be fine, all right? We would obviously cut the metal before making it to the correct length. And that'd be it. But on the adjustable dipoles, we need to put a slot in. Okay. Now to do that, we've made this very simple. I'm going to call it my homemade slot cutting machine. All right. Now, some linear tracks. You can just see the tracks here and here, either side of it, and it pivots backwards and forwards. And just under here is a circular saw blade. All right. And this cuts the slot into the dipole. Now I'm going to do it. It's very noisy. All right. So I need to put my earplugs in, and of course safety goggles. I'm probably going to mute the sound for you guys because it is very loud, all right? But we're going to cut the slots in now. And there you have it. Perfectly aligned. Nice slots in the end of the dipole. Now there's one final part we've missed, okay? The dipole's made, it's ready to be used. We need a boom arm, a mounting arm for it, okay? Now I'm not going to show you me cutting the metals, that's pretty straightforward. There's a chop saw behind me, and we simply chop the metal up into the right lengths, and the same goes for the elements. So here's a bit I've cut, okay? It's 1-inch boom arm, 18 gauge. We need to deburr it, same as we did with the elements. Okay, so we deburr the ends, just finishes it off nicely. Now I used to mark all these out, measure down, mark where I'm going to drill the hole, and drill the hole, all right? It took me forever. And it didn't look very professional, because you can tell when a hole's been drilled with a normal drill bit. It's fine because I had a little deburrer as well to neaten up the hole, but it took forever. So I made this little bad boy here. It's a little hole punch machine. I drew up the parts in AutoCAD, and this simply punches the hole for me. All right, now there's a little hole there, and there's a little locator pin below. So when you punch one hole, you can rotate it round, line it up, punch the next hole. All right, so I'll show you that working now. This is connected up to an air compressor, a very powerful air compressor. We've got this set at about 15 bar, I believe, so there's a bit of force behind it, all right, to punch through this metal. But I'll show you that now, all right? So the pole simply inserts over there, like that. Press the lever, punches the hole, locate it round, and feel it click in. Again, take it out, perfectly punched hole, there you go. And that's how we make our boom arms. Now, if you was doing, let's say a Moxon antenna or something that required holes at each end, to line these up, bear with me. You see these tracks here? We simply use this. So this sits through like that. That sits on these tracks. You can't see it on camera. It sits on these tracks, pushes it in. Let's pump that down a bit. So we can punch the next hole. Okay, you simply take it out, turn it around, put it back onto here, pop it back into the machine, and it gets jammed on camera, typical. But that is how we make the holes in the boom arms. Now, unfortunately, it's got jammed for the video. I know why, because I've got the machine normally stands up on its end, and the little bits it punches out drops out the bottom. I haven't dropped out the bottom on this occasion, so it's jammed up. But that is how we do the boom arms. And then we simply, once we've finished, we've got nice stainless steel hose clips. Bear with me. They go over the ends, just like that. We use stainless steel and everything as well, all right? Even the bolts, because in time, if it's not stainless steel, it's going to rust. Even if it's coated in whatever it is they coat it in, it's going to rust. So I make sure you use stainless steel and everything as well. So there you go. We've made a Ceecom dipole, just like that. Thanks for watching, guys, and I'll catch you soon. That was quite long-winded, wasn't it, Andy?
No, it was very good, actually.
It was
That's
brilliant.
amazing.
Yeah.
I've got a question.
No, the answer's no.
So, thanks very much. That's
Yeah, that was
absolutely
brilliant.
captivating.
Yeah.
You are so creative and inventive, and massive hats off. I mean, fantastic. Here's my question. So your dipole elements are aluminium, and those what look like pipe olives that you crimp on are made of brass. So you've got dissimilar metals there with a junction in between them. Have you seen any kind of electrolytic effect of that junction causing problems?
No, never had a complaint.
Okay.
What I also do, not shown in the video, on the higher power stuff, so if it's an N-type connector, where the ring's crimped on, I drill through from each side, and the little 3.5mm rivet goes in as well. So it acts like a solder lug type thing. But no, I haven't had any complaints. I know exactly what you're talking about, because I've got a bit of aluminium up in the garden supporting a bamboo plant, and I've got some tinned wire on it, and it's all turned black. But no, I know exactly what you mean. No complaints as yet. I've got what I often do as well. I've got other fittings here for the collinear I was talking about, where it's like cast aluminium and so on. I drive the wife mad because I leave a lot of parts in the freezer for sort of a month at a time. So I like the fittings you're just talking about. And then I bring them out the freezer and quickly see how brittle they are and see if I can snap them. A lot of the stuff as well, leave out in the compost in the garden. It's all scattered around aerial parts. Just do every test I can to see if there's any effect. And, you know, if it becomes brittle in the weather. So try and sort of speed up the weathering process. But so far, that's the best way I've come up with of mounting the wires onto the poles.
Brilliant. Thank you very much.
Go on, Andy. Any more questions, Andy?
I've got a question, Mike. If you can hear me, it's Chris here.
Yeah, go on.
When we were chatting up in Newark, you mentioned about testing the radiation pattern of your aerials. How do you? I know you model it on the computer, but how do you actually test it separately as well?
Yeah. So what I do is, people are going to gun me down now. It's not the correct way of doing it, but it's my way and it works. So obviously, do the modelling on. I use 4NEC2, I think it's called. So doing the modelling on that. In fact, I can probably show you some now. Then in the garden, bear with me. Oh, it's typical. I'm not going to be able to find it now, am I? Well, I model it and I print out the plots, and it gives you a really good computer-generated model. Now, in the garden, I've got a Clark telescopic mast. When I've done the garden, we had artificial grass and so on. And in the centre of the garden, I've got a nice hole that goes down in concrete that the mast slots into. It's quite crude, so I will transmit a very small amount of power from maybe the analyzer with a very small amplifier on it. I don't know, probably 10 dBm. It generates a small signal from the antenna. And then at the side of the garden, I use SDR, and I've got the analyzer here as well, which gives accurate readings with a small dipole at different heights. And on the Clark mast, I literally tape on an arm sticking out with 360-degree template on the ground, and I literally, with it transmitting slightly, I pull a rope off it that's wrapped around to turn the mast. I need to buy a rotator. And I rotate it 5 degrees at a time, take a reading on the dipole, the signal strength, rotate it again another 5 degrees, and I'm not going to say 10 times out of 10, probably 7 or 8 times out of 10, it gives a very similar pattern to the model on the computer. And then I do that at different heights to test. I was recently doing it with a radio station that had 2 dipoles back to back, and they couldn't understand why they could only hear the signal in one direction. Obviously, they null each other out, and it becomes a very directional antenna. But they were setting up the 2 dipoles thinking that, bear with me. I've had a mast like this with 2 dipoles on like that. And the way they set it up, they thought the signal was going that way and that way. But in actual fact, where it cancels out, it was going the other direction. They didn't believe me. So we've done the simple test with that in the garden. And it was pretty much bang on what the computer generated on the model. So yeah, that's our testing, Chris. It's not the correct way. I've not got a nice chamber and everything, but it works. And if I model an antenna, I do a lot of stuff for I can't say the company name, but they supply antennas to Arkiva and Ofcom for radio stations and so on. And every one of them antennas we supply has to get approved by Ofcom. And it has to have an accurate model and test. So that's exactly what we produce, that test, and that's good enough for Ofcom. So
well, if it works, it works. Doesn't it? Yeah.
But yeah, that answers that, I hope.
It does, thank you.
Yeah.
Sorry, I lost you.
Anyone else got any questions?
I like the way it injection molds it. So yeah, really good with that.
Brilliant. I've got another mould here. I'll just show you quickly. Bear with me. So on the commercial stuff we do, or I do, not we, there's no we, got this mould here. And this is for a folded dipole used by DAB radio stations. The elements go through there. Coax comes in here, and there's 2 mounting points there. And it folds round into another fitting on the other side. Now, the top of the mould there goes in, and it creates a hollow mould. So what we do, I've not got any to show you, unfortunately, but that creates a hollow mould, and then we do a lid that goes on the top. And for some reason, they asked that they're filled with resin. I'm guessing they present us going to last longer than the plastic. So the ballon and stuff goes in. It's a little ballon wound on the back of coax, 4-to-1. It's like reverse. The centre core's wound on the outside. That sits inside, and then the resin's poured in over the top. A bit like the commercial dipoles you see up on all the towers and that. So we do that as well. And I'm going off on one now, aren't I? And all the other little fittings as well we mould. So like these, bear with me. So we just, I didn't mention it earlier, Andy, we've got another antenna I'm doing with a gamma match on it. This fitting isn't mine, this is one I bought, I was just testing it, but mould these, and this is going to make a nice gamma match on. We've got Teflon PTFE that's going to be inside there with your adjustable capacitor, because I've not found these anywhere being sold. They don't exist, so I thought, sod it, I'm going to make them as well. And I've got a little crimp as well for this part here, which punches a hole through and so on. Another machine I made. So yeah, that's that.
I've got another one.
Go
on. Do you make your own moulds, or do you sub that out to somebody?
No, when I first started out, I was 3D printing the moulds. Then I'd put the 3D print inside plaster of Paris, mixed with dried kiln sand, mix it all up and sink the 3D printed mould inside the plaster. And then I'd really upset the wife, because I then put the plaster in the oven in the house and allowed a plastic mould to drop out the inside of the plaster. And then I'd heat up aluminium in a kiln and pour the aluminium into the plaster to generate an aluminium shape of what I'd printed out. But obviously a 3D print is nowhere near as good as a CNC machined mould. So I draw these in AutoCAD. See if I can show you the final mould of the new one coming out. So for that part I showed you earlier.
Yeah.
I don't know if you can see that on the screen.
Yeah.
So yeah, the part I drew, I then implement that into this block. Now that's been sent off. I use a company out in China, because to get the CNC machining done in this country is thousands and thousands, and China seems to be about half the price. So a little bit on shipping, because these are really heavy. But yeah, so that's how we get the moulds done. So I just send them off now to be machined. It's just so much easier. But they're not the cheapest. So for like the part for that gamma match, the mould for that, I'm probably never going to make my money back on that, considering the price of the mould. So like you were saying earlier, Andy, when people say they can make a dipole for £2, you can, but making them like this, you've got to take the cost of the moulds and stuff into consideration as well. So because they're not cheap.
Well, Mike, a non-technical question. So how on earth do you find time to do all this?
Chris.
I don't. Job. Not just the making the aerials, but also all the development, all these things we've seen tonight, where you've had to make the machines yourself, sort the moulds out, all that research that you got to do, testing and all the rest of it, design work, and then you got to build them as well as having a full time. How on earth do you do it?
Well, there's two bags there, Chris, and I don't really. I've got a 2-year-old little girl, and obviously, like this weekend, trying to fit in family time and. Yeah, well, what happens is really the products aren't getting made quick enough, if I'm truthful. I've got a waiting list at the minute for J-poles. On the website, you can click notify when a product's available. I've probably got 50 or 60 requests at the moment for the Moxons. So they're either too cheap or I don't know what I'm doing, but I need to find time, Chris. You're absolutely right. I don't find time. And it's a tricky one. My wife keeps telling me to leave work, so I work full time as well, and do this full time. But unfortunately, I don't think antennas would meet my wages I earn in my day job. So it's getting the balance right. So it's still just a hobby, if you like. I just enjoy making things, and we'll see what happens. If I'm free and single next year because the wife's left me, then there'll be lots more antennas available.
What sort of Moxon do you make?
Sorry.
What size Moxon do you make?
So at the minute, we're just using the standard moulds that I've showed you, 2 metre, 4 metre and 6 metre. This bigger mould I just showed you on the screen is going to allow up to 1 inch tubing. So I had loads of requests at Hamfest for 10 metre and 11 metre Moxon. So we're going to be making them. But I've scaled it enough to go right down to 14 megs, 20 metres. So we'll be
that's
going
good
right
because that's my band that I like.
Yeah, I could probably go lower than that, but it's going to be, it just becomes too big. And the other problem is, easy to make the Moxon bigger, but this stuff needs to collapse down to be able to be sent, via courier. So that's always a challenge as well with designing an antenna. Like the Collinears, the 4 metre ones, for example, it has to break down into lengths up to sort of 1.6 metres. Anything over that, then the postage goes up to like 40, 50 pounds. And then it, outweighs the cost of the antenna. So it's really hard trying to get it right. Like the cobweb I'm making at the minute, because I want to be able to send some overseas as well. So I'm trying to get it to collapse down to 1.2 metres, but at the same time maintaining the strength. So it's a balancing act. It's really tricky. But yeah, so we'll be going down to the answer to your question. Yeah, we're going down to 20 metres.
Oh, that's good.
Yeah.
I watch this space.
Yeah. Any other questions, anyone?
Yeah, one from me. Can you hear me?
Yeah.
Can you hear me, lads?
Yeah, I can hear you.
Oh, that's right. I was not sure. Earlier on, Mike, you were talking about where you encapsulate the dipole in that black plastic, and that you have to accommodate that because it always makes a difference to the capacitance in there, correct?
Yeah, it doesn't affect. It's all right, sort of down at 50 odd ohms. The most effect I've noticed is up on the folded dipoles. When you jump up to 300 odd ohms, it really makes a difference. It's been a real pain in the arse, actually.
What I was going to say was, instead of doing it in black, which everybody uses, could you not do it in a light grey that obviously won't have the same effect as the dark plastic? Because obviously it's got a carbon content, the black, hasn't it?
No, it's not carbon, apparently. I could go on for another hour how I source this plastic. Because at the start, when I first started making antennas, I tried all sorts, HDPE, polypropylene. So this plastic, I don't want to give away my secrets actually on camera, but no, there's no carbon in the plastic.
Okay, fair enough.
So, but there must be something for it to be causing this capacitance problem. But it may not be capacitance. It's probably just where it's surrounding the components. A bit like I have the same problem with the white stick antennas. As soon as you slide the fibre line, like the end-fed, like the X50 or the X30, you can tune it all up lovely on the bench and outside tune. Like the minute you put the fiberglass tubing over it, completely throws it out. So you have to tune it, put the tubing over. Because I see a lot of videos on YouTube and people take them out the tubing, then do the test and give certain antennas a bad review. But what they've not realised is they've taken away the tubing around it, which is completely changing the tuning.
What coating have you got on this white stick on the fiberglass?
To be honest,
Again,
I couldn't tell you.
Yeah.
I buy the shells in on the fiberglass and I make the insides.
Ready painted?
Yes, I'm going to be honest, I buy the shells straight from Diamond. So they're exactly the same fittings.
I'm just well, I mean, I don't know how they tune their aerials, but you're obviously finding that does make a difference. I'm just wondering what the coating that's on the fiberglass consists of. Because, I mean, let's be quite honest, fiberglass is totally inert, non-conductive. I wouldn't have thought it would have made any difference.
It's the, I can never say this way, it's the dielectric, it's a bit like a coax, isn't it? If you've got an air gap around the coax, like your Massey and Palomi, or if you've got a solid plastic around it, it affects the velocity factor and all sorts of other technical bits. I'm going to be honest, it gets so technical that I don't understand it all. But I will find out. You've asked a good question there. See what it's coated in. Yeah.
I'm not fully convinced about this, what you've just suggested. Theoretically, RF's no different to running a current up the centre of the area. I mean, all right, no, it behaves in a different way. But basically, if you was to try a piece of clear fiberglass over it, it'd be interesting to know if that affects it rather than the one that's coated with a white paint or whatever they use.
I'll try. I've actually got white on the brackets I make. I do white ones for marines, for boats. I'll try moulding an antenna in white, and we'll see if that makes a difference.
It'd be interesting, curious.
Yeah, it's a good point you've made there. Definitely. Yeah, we'll give that a go.
Don't forget, you don't want to spend all your time pouncing about with coat and paints when your wife's waiting for you to take over with the bab occasionally.
That's right. That's right. There we go. Right, we've got a competition to run as well, haven't we, Andy?
Yes, mate. Yes, we have. Everyone's a winner.
Have some fun.
Yeah.
So can I ask a question about that? There's a user here that's just shown us 2E, and I don't know what their call sign is.
That's John Fairbrother. He tried to log in on one and then he's logged in.
Oh yeah, I tried to come in on the on my phone.
So there's not
because my internet dropped out on the bloody house one.
So there's not a 2E.
Okay.
Good.
So yeah, sorry about that.
That's all right.
Just trying to confuse you.
So
right, so you're going to do the first one, Mike.
Yeah, we'll do the first one here. Right,
okay,
so
mate.
Let me fold the laptop down. Bear with me. Right, so we'll use this tub. All the names are in there. We'll give them a little mix up. You want me to draw one now?
Yep. Go on, you draw one now.
All right, I'm not looking.
Oh, look, it's M0IRU. Thanks, Mike. Lovely.
So 2E0ZAP, Robert Bird.
Robert Bird, right, okay.
Okay, I'm guessing, are they online?
No.
Okay, right. I'll keep that safe, and
Perfect.
I will send them an email, and
wonderful.
Yeah, and they can choose the dipole of their choice. Yeah.
Yep.
Right, and then you're going to do the other two draws, correct?
Yeah, Jonathan, you want to do one?
Shall I share my screen so that you can see what's going on?
Yes, please. Yep.
Share screen. I'm actually going to share this window here. So, can we all see this?
Yes.
Yes.
Covered.
So what I'm going to do, I'm going to keep pressing this button. Andy's going to tell me when to stop. And the number that's present when I stop will be the winner of this one. How's that sound? Everybody happy?
Before you do that, is this for the 2-meter Moxon or the antenna of your choice?
2-meter Moxon.
Okay.
Okay. Tell me when to stop.
Number 7 ain't come up.
2. It's me.
I think you should.
That's a fiddle.
Oh, I'll do it again.
No, go on. No, it was 2. That's fair. Just because it happened to be you, it's irrelevant. It's fair.
Guys, I can show you the formula. You can see it's.
No, you don't have to explain. Run it again. We've got now one of your choice, Mike. The third.
Am I doing another one then?
Yeah. Run it again.
But you can't land on 2 this time.
Yeah.
No, that's fine. If it lands on 2 again, I'll stop it. Andy, tell me when to stop.
Stop. Number 12.
G0CIB.
Who's G0CIB?
Can you organise it, John, so it stops on number 8?
Wonderful. Thank you so much.
What antenna would you like?
What antennas are there?
So we've got, well, if you go on the website, you can choose from there if you want. What's in stock? We've got 6-meter J-pole. We've got no 4s at the moment, but they'll be ready in about 4 or 5 days if you wanted to wait for one of them. Dipoles of your choice or any of the white sticks, X30, scanner antennas, marine airband. Or do you want to look on the website and get back to me?
70 cents. You got anything for 70 cents?
Yes, but you're probably not getting your money's worth there. It's a very small dipole. That's all I've got.
Doesn't matter. A dipole for 70 cents is perfect. I've got a perfect use for it. Wonderful.
Perfect.
Thank you so much. Much
No
appreciated.
problem.
A great talk.
Thank you.
And now, Mike, we've got to talk about what my price is.
Well, I'm not stripping naked again, Andy.
No, not again, not again. Once is enough. Once is enough. We only do naked.
We all learned what happened last time.
So I think I should win a visit, a day trip, Beano to Ceecom antennas.
All right, we'll sort it out.
Building. Right, we'll do that. Okie dokie.
We'll sort it out. We'll make a nice little YouTube video.
For how many people? 4?
There's not room for 4.
I think it needs to be at least 6.
3.
Mike, where are you
standing
based?
from outside?
I'm in Harlow, Essex. Sunny Essex.
not far. Yeah, put my
Up
name
north.
down for
Are you really trying to get Mike divorced to you by getting like 10 mil around his house?
More antenna building or more hands antenna building. Yeah.
Yes. Yeah, £2 an hour, Andy. That's what I'll pay you. You can come and make antennas all day.
He's not worth £2 an hour.
No, we know.
And not
Thank you
only
very
that,
much.
Mike, he needs to turn out at least 50. Don't let him stand about cackling.
Yeah, no standing around chatting. No, I'll arrange something. I'll come down to it.
We'll sort something out. Yeah, I'll go. Yeah, come down. Give it.
You ain't a million miles away from me.
Let's get
Nearer me.
Let's get a few bits out of the way and then come over. I've got I've got a nice little project I'd like to test with you. The 10 gig stuff that's coming out, little balls.
Yes,
So play with that.
okay. All right then. Well, if it's 10 gig stuff, I'll tell you what we'll do. Me and MLO will come down and have a.
All right, deal. Yeah.
And we'll do that. So me and MLO will.
I tell you
have
what,
a day out.
there's a couple of dodgy
Jolly boys
characters,
out.
Mike. You be careful.
I will. Don't you worry.
Mike, have you thought about taking on an apprentice?
No. 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 Just
What's
no.
his name got to be? Jonathan Groves?
No, not at all. I was just thinking, I mean, it would help give you a bit more capacity, and wouldn't cost as much as a kind of permanent employee. It was a sensible, it was a sincere.
Don't forget, Jonathan, he's doing this in the evenings as sort of part-time.
Yeah, I work full-time. Well, I think the next step would be, being serious now, I actually need a workshop, a bigger workshop. Because at the minute, I can't even turn a piece of metal around and I have to go out the door and back in and so on. So everything's taking a lot of time. I have to pack one machine away, get the next one out. If I had a nice little workshop, I could do much bigger stuff as well, move on to the beams and so on. So that's the plan. But like I said earlier, to quit my day job and do this full time, I don't think it would pay as much, if that makes sense. There's not much money in antennas, believe it or not.
No, I agree with you.
How these other companies do it, I take my hat off to them. All the other antenna manufacturers.
Well, Mike, it's because the other manufacturers aren't as they aren't as good quality as yours, and yours are cheap. Frankly, you probably should be charging more money.
Oh yeah, definitely. But that's the beauty of Ceecom, Chris. That's what I like, and I hate it when you see something advertised. It's hundreds of pounds, and when you get it, you know what it's cost. All right, there's some work involved making it, but I think that's the beauty of Ceecom at the minute. I'm not making very much on each antenna, like you see at Hamfest recently. Dipoles for £22. You just see the effort that goes into them and the cost of aluminium and so on, fiberglass tubing and everything involved, the clips, and then the packaging as well adds up. So I'm not, on them £22 dipoles, I was probably making about £5 an antenna. So you are right, they're too cheap, but I'm a people pleaser. So, and I like it this way as well. As I've been approached as well by a lot of the shops, as we spoke about at Hamfest, Chris. Some of the big boy shops are asking for the products in there, but they would want to put the price right up. Yeah. And I probably couldn't keep up at the moment as well with what they want, the demand, if they did sell. So I think at the minute, I like what I'm doing. It's a hobby turned into a small business. Maybe in the future, I'll get a bigger workshop and start churning out stuff. But yeah, Now we've moved house and that as well. We had a little baby. She's 2 now. I'm getting a lot more time now. So hopefully by next year you should see a lot more products coming out.
That's good. No,
Don't forget that's how Martin Lynch started, mate.
I think the unique part of Ceecom antennas for me, to be fair, and all jokes and laughing aside, is that whenever I've wanted to speak to, like for example, if you were going through a retailer, I lose the connection with you. Whereas now I can get in touch with you via your website or messenger or etc.
Well, yeah, you're right there.
I can actually connect with you and say, look, I need an aerial that's going to do this, this and this, or perform in this way. I need it to be able to do this. What would you suggest, or what can you build, or what can you make? And I'm liaising with you. And the very minute a third-party retailer becomes involved, yes, you're right with the price, etc., but that's then lost. I lose the connection with the builder, and it just becomes a do you want it or you don't kind of thing. And that's where you are, Ceecom antennas. It's nice to have that interaction, and it's nice to see when you're at the fairs and it's not being sold by, you know, the multi-pools. You're actually there and you're selling it and you're engaging with everybody, and it's like it's your product. Do you see what I mean?
Yeah, you're absolutely right. Yeah, I've made a lot of friends that are customers, you know, and if anyone's ever got any problems as well, yeah, straight away contact me and I'll sort it out, Andy. You know, I'm not gonna argue over it. It's you know, however, I have had to take my number off the website because I do it by contact form now, or Messenger or Facebook, fine. Because what's happening, as we spoke about before, I've been supplying helium mining antennas as well.
Yes.
And these were selling by the hundreds, and I just got so busy. I was out here every night making them, and I was getting some days, you know, 50 or 60 calls. Mike, what do I need at my location? So, and I started letting people down, so I couldn't answer all the calls. I could, but then the antennas weren't getting made. So, yes, at the minute there's a contact form on there. Reach out to me and I'll give you a call straight back if you want to talk to me. But yeah, definitely, Andy. I wouldn't really want to go for a third party. I'd like to talk to my customers and so on. You know,
Mike,
I've got a question. Where did you source your alley from?
Cool. You asked me some questions now. Aren't you?
Is it local to you?
It is.
Is it local?
Yeah, I use a couple of online companies. Some companies can't do the lengths I want to get the cost down on them, but yeah, it is local. Yeah.
Okay. Yeah.
In fact, it's not a secret. I use Aluminium Warehouse. You know, if you search online, you're going to find it. So, Aluminium Warehouse and Metals for You is called.
Did they actually over the counter you go in and buy it if you've got to order it online?
You have to do it online.
All right. Okay.
Yeah. So the prices have gone up recently. The length of the 5/8 aluminium tubing is about a tenner now. So yeah, but I've not put my dipole prices up to compensate. So take note, people.
I didn't want to know how much, but I want to know if it was local to you, because you're not very far away from me. So
right, yeah, it's quite local. Yeah, I do collect a lot of it. The beauty is when it arrives by courier, it looks like it's 10 years old already.
Yeah,
they just throw it in a cardboard tube and package it at all. So yeah, I go down there regularly and collect. But yeah, it's no secret. If you search online, you're going to find aluminium. So yeah, there's nothing to hide there. So yeah,
I used to buy it in 5 and 6 meter lengths.
Right. Yeah, that's right. Yeah, it gets pricey on the shipping. Then the only thing I've not been able to source in this country is the like I said, I buy the white stick type antennas like the X30s and so on. I buy the shells.
But they play a blinder, don't they?
Sorry?
I bet they play a blinder, don't they?
What do you mean?
White sticks.
Funny. I get it. But yeah, I have to buy them in from. There's no company in the UK that seems to supply a white gloss fiberglass tube at the size I want. So yeah, they do come in from abroad, and I have to buy quite a lot of it to get it at the right price. So
Does it come from China?
it does indeed. It does indeed.
You know, if anything happened to China, we'd be lost in the Western world, wouldn't we?
Yeah, but some of the antennas that come from China, they are shocking.
Mike, another question about the antenna. I've seen your slicer machine for cutting the ends, the grooves into the end. Brilliant idea.
Yeah.
That's really clever. Why do you do that and not use a screw instead? You actually put it together with a self tapper.
Because on the larger ones, you get the Jubilee clip and the screw. The screw allows you to line it. I'll answer your question in a sec when I show you this. That's the wrong mold, bear with me.
New lawn, don't we? You got a new lawn.
What I normally do, which I'll be doing in the future, you see this mold here, the dipole, that tube could fit in there like that, and it puts a little fitting on the end. There's two on the other half of this mold. You see that there? Two little nuts go in there. That sits in, and it puts two screws that you can wind in and out in a piece of plastic. So you can adjust the ends in and out. It just looks a bit nicer. But what you're just saying about this self-tapper, when you, let me get another bit of tubing, bear with me.
Look, there's stainless steel script self-tappers, Mike.
Yeah, I use stainless steel and everything. But when you put that inside there and you put the screw in, okay, a lot of companies, when you buy a dipole, only give you about 2 inches to insert. I like quite a lot to go in for the strength. Now, when that goes in, put your self-tapper in. You could put a second one in.
Yeah.
But if you listen, this end is about 0.4 of a mil, and you can hear it moving about inside.
Right. Okay. Yeah.
And you can actually see that if you're listening to a very weak signal on SDR or something, you can actually see the metal. You can see it on the signal. I don't know what it causes, but probably not static, but it causes some sort of effect on the antenna. So by clamping it in, you don't seem to get that movement with a Jubilee clip. If that makes any sense.
Yeah.
That's why I do that. But yeah, like on the J poles and so on, you have the Jubilee clip because there's quite a bit and there's still that slight movement. You'll notice there's a screw on the back as well, so the self-tapper goes in, and that's what we do on that. So, but yeah, good point.
I take it you do all your adjusting for the SWR and things off the other pieces that go in. I understand that. Whereas that's the fix, the middle's fixed, and then you add your bits to the other end, don't you? To either end, add your rod to the other end, and that's how you alter the SWR, I suppose, is it?
That's how you tune it in, make it
tune it up,
yeah. Now on the bigger stuff like the J poles, I've set up a load of jigs or the Moxons. I'll just show you this. So again, quite very crude. These are only temporary, but I made lots of jigs up like these. So this is for the Moxon. That's the end part. It goes around. The fiberglass tube goes across here, and it gets crimped in. So the mold makes it. The jig makes it really accurate. To get every Moxon the same, and the same with the adjustable elements on the J poles. I've got jigs, little parts that clip on. So every single element is machined exactly the same. So I can use one fixed piece made up outside in the garden to tune them all. And I know that everyone in the packet, when you get it, packaging is the same, if that makes any sense.
Yeah. So
it's quite a lot of, I bloody hate tuning antennas as well. It drives me mad. That's the worst part of making them. You have to then take them all outside. I like to check every antenna as well. I don't just throw them in the bag and hope for the best that everyone is set up and tuned on the. I just use this Rig Expert now, or this analyzer here, a little less SWR bridge. It's quite accurate, but this is just handy out in the garden. They work really well. Yeah. So yeah, it's a lot more involved than just throwing it in the bag.
Yeah. Well, I think
that's what I want. Yeah.
I think what I'll do now, Mike, is I will turn the recording off.
Okay.
Thank you very much, mate. I really
do. Thank you for having me.
No, I'll get you back. Don't worry about that. Now you've done one, you know there's more, whether you like it.
You're getting blocked now, Andy. That's it.
Yeah, that's all right. I'll
Give
just
him-
put somebody
give
in
him-
place.
Andy, give him 3 months, see if he's progressed, and we'll nick his ideas then.
Right, let's stop the recording.